Well, hello everybody. As you can see, I am looking at the bonus quiz for 1.6, and this is one particular version of it, and it's one that gets to the essence of what I want to talk about, and that is this moment in the course where we start to see symbol overload. This is a particularly treacherous moment. Now, you went to grammar school and you got exposed to the subtraction sign, and that was used there as a binary operator. It takes two things and makes one thing. 8 minus 5 is 3. And then later on, as you went on in your math education, you got exposed to the negative symbol. It's the same symbol, but it's used in a different way here. It's now a unary operator. It says take the opposite of 5. And so, in a sense, we can write subtraction as the addition of a negative number. And all of that you should be familiar with. In fact, here is an example of that we're going to see a lot in our course. The idea of a double negative being a positive. This says take the unary operator says take the opposite of 5, and this says take the opposite of 5, which is a positive 5. And I would say to you that it's even part of our grammar. For example, not unhappy is the same as happy. Not is a negative sign, un is a negative sign, and a double negative makes a positive. So it's built into our grammar, this unary operator, the negative symbol, and you got exposed to it in your math courses. And now here we are with yet a third use for the negative sign, or the subtraction sign. And in this case, it doesn't mean negative and it doesn't mean subtraction. It means negative exponents mean division. So that's a huge fence to get over. We're overloading this symbol here to mean three different things, and even worse, where we're headed is a fourth meaning to the symbol. Now this is not even an exponent in this case. This is functional notation, and we'll eventually get to this. It doesn't mean an exponent of -1. It's doubly treacherous. But this means, in this context, this means take the inverse of the function f of x. So that's in our future. 4 different uses for one symbol. That's called symbol overload, and you could see why I need to flag that. It's incredibly easy to spin out of control when you have one symbol doing 4 different things. Now, one more thing before I solve this problem, and that is I wanted to show the underlying beauty of the mathematics as to why negative exponents mean concentrated division. Now you know that positive exponents mean concentrated multiplication. This is really 5 times 5 times 5. This is really 5 squared. This is 5 times itself one time. And then here is something new, and that is the integer 0. What does it mean to raise a number to the zero power? And in this course, we're going to have a quick retort for that. Anything to the 0 power is going to be equal to 1. We're going to say we're not going to even think twice. Anything, it doesn't matter how complicated this is, to the 0 power is equal to 1. And that's a bit of a simplification because 0 to the 0th power is in dispute, and you can research that in your own time, but it's beyond the scope of our course to bother with 0 to the 0th power. Anything to the 0 power for us is going to be 1. And so another underlying pattern here is, notice as we go from here to here, we have divided by 5. 125 divided by 5 is 25. 25 divided by 5 is 1. 5 divided by 1, 5 divided by 5 is 1. And 1 divided by 5 is 1/5. And 1/5 divided by 5 is 1/25, and so on. See, so what happens here is we have concentrated multiplication until we hit this point, and then we have concentrated division. And so I think that should help solidify this idea of negative exponents here as being concentrated division. And I'm ready now to solve this. And my first move was to actually just create some white space to show you that the 4 is to the negative 4th power, and that minus sign, that negative sign is out front. It's not being touched. It's not being raised to the power. So you could of course do this in your mind, and I do, but for now I wanted to create that white space to show you that this thing is outside the negative 4th power. Now we know this means concentrated division, so I'm going to have 1 over 4 times 4 times 4 times 4, or if you will, 1 over 4 to the 4th power. And so now all that's left to do is to crunch this out and to get rid of the white space. And I thought I'd bring in my calculator to show you the key that we'll use for that. That's this key right here. It's found on most scientific calculators. The first number in becomes the y, and then I hit this key, and then the next number in becomes the x. So if I wanted to raise 2 to the third power, 2 to the third power, that is 8, 2 times 2 times 2, I would type in 2, I'd hit that key, that becomes the y, and then I'd say the third power. I don't need to hit it again, I go to the equal sign. So 2 to the third power is equal to 8. Well, we have 4 as the base, and then 4 as the power, and so we get 256. And so the answer here is going to be, with the white space removed, it's going to be 1 over 200, negative 1 over 256. And so all that's left for me to do is to click WebCT Live and to enter that answer. And so I choose a fraction, and I'll say negative 1 down arrow over 256, and we'll say submit. And of course the green arrow. So I hope that helps. Keep in mind that idea of symbol overload and flag yourself for it. And I'll be talking to you again soon.